This is pre-calculus lesson 2.1, day 1, introducing quadratic functions again. This first slide should be a nice review for you. We've already been talking a lot about parent functions of quadratics. The blue equation is what a quadratic equation looks like when it's in factored form. The green one is more what we've been working with when it's called vertex form, where we identify the critical point. Remember that your H and your K help you with that critical point, and you can apply the transformations to it. And then the last equation is what we call standard form, not the most popular form. If you'd like to write them down, you're welcome to do so. We will refer to them throughout this section. This is a 2-day section. Day 1 focuses on introduction to quadratic functions and be able to graph them, where 2.1 day 2 does the opposite. We give you a graph and we want you to come up with what the equation is of that function. So what we're going to do first is we're going to just review the parent function for our parabola. I'd say this is already in your notebook, so you don't need to write it down. So remember, the parent function of the parabola is f of x equals x squared. You can also rewrite it as y equals x squared. So when we were doing this in our chapter 1, we made an xy chart and then we plugged in some numbers. So 0 times 0 is 0. 1 times 1 is 1. Negative 1 times negative 1 is 1. 2 times 2 is 4. Negative 2 times negative 2 is 4. And then we went over and graphed these. So here is 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. And then we talked about this parabola opens up. It has a critical point of 0, 0. This is what we call the critical point or the vertex. All right. I would say this slide you can just kind of listen and watch. We've already done this in chapter 1. So we'll focus on what if they give you an equation that's in vertex form. My recommendation is to find that critical point first, the vertex. What does it move right or left, and what does it move up or down? Then identify all the transformations that happen to it. And then graph the vertex and apply those transformations. Remember, these transformations on this slide are already in your notes. Remember, the purple is if you have a negative inside the function, it's going to move it to the right. If you have a positive h inside the function, it's going to move it to the left. Think horizontal shift changes. The orange is what moves it up or down. That's outside the function. So if it's a plus k, it's going to move it up. If it's a minus k, it's going to move it down. The reflections. If the negative is in front of the function, it's going to reflect it about the x-axis. So remember, a negative a flips it down. Negatives inside the function don't actually change parabolas. When you reflect it about the y-axis, you'll still be left with that same parabola. The last two are the green and the blue transformations. Vertical changes are multipliers of a in front of the function. Think of those are your stretches, your compression. It's changing that y-axis. So you multiply every ordered pair by that a. The blue is a number inside the function, inside that parentheses. And what we have to do with those is reciprocate that number and then multiply every value of your ordered pairs of x by that multiplier. And those change the horizontal axes. All right, so what we're going to do is we're going to do some examples here where we're going to graph the functions from its transformations. This should be a review for you. You probably can just watch and listen. If you do want to take notes, you're welcome to do so. So here is g of x, which equals x minus 4 all squared plus 5. So we want to identify the critical point. The critical point, in this case, is going to be right 4 and then up 5. So in my notes it says, go ahead and graph that point first. So here's 4 and then 5. Then notice there is no multipliers in front of the function. There's no multipliers inside the function, so my shape is not going to change. So remember my parent function. Looks like my smartboard needs to be recalibrated here. Should be 1 right, 1 left, up 1. And then we go 2 right, so now we're going to go up 4 and 4. And there's my parabola. Moving on to the second example. The critical point for this one is 0, 0. We're not moving right or left. So there is my origin, 0, 0. Now remember what happens when you have a negative inside the function or in front of the function. This negative reflects it. About the x-axis. No changes happened in the shape of that graph. That should be through 0, 0. Again, my smartboard needs to be recalibrated. Okay, our last two of these in vertex form. Our critical point this time is right 0 and then down 3. Now there is a multiplier that is going on. Remember, that changes all of your y values. So here's your y-axis. It's going to increase it by a multiplier of 2. So normally we would go up 1, but we're going to go up 2 instead. Then the next right 1, left 1, instead of going up by 4 from the vertex, we're going to go up by 8. So now we'll be at this point and that point. So we'll be at 2, 5, and negative 2, 5. Again, remember, this distance from here to here is 2. This distance from here to here is 8. Normally be 1 and 4. All right, our last example of transformations, our critical point does not move right or left. It stays at 0, 0. Then notice there is a 1/3 inside the function, a multiplier. So we have to reciprocate that 1/3 as 3 over 1. And what it does is it changes the x values, the x-axis. So in this case, let's graph that parent function quickly again so you can see the difference. So normally it'd be 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. So here's 2, 4, 1, 1. What will happen is all of my x values are going to multiply by 3. So my 0, 0 still stays as it is, but now my first x value, instead of being at 1, is going to be over at 3. And then up 1. Then my next x value, instead of being over at 2, is going to be 2 times 3, which is 6. So this would be 6, 4, and this is going to be 3, 1. And remember, I do have that symmetry. So now it's going to be left 3, up 1, left 6, up 4. I'm going to stop the recording there, and we'll go on to the next part. We're at about 9 minutes.